Hello students, welcome to the introduction of network hardware. Let's begin with the basic network hardware components: network interface cards, cables, connectors, servers and workstations. NIC card is, you can say, the backbone of the network along with the cables and the connectors. And the main devices which we use the term client and server, that is server or workstation. Apart from the components, there are internetworking hardware components which are used to connect two networks together. When I use the term inter-network, that means two networks are connected together. So to connect two networks together, we need different hardware components which are repeaters, transceivers, hubs, bridges, switches, routers, and gateways. As we go further through this lecture, I'll be explaining each one of this one by one to you. So first we begin with the intra-networking components. Intra-network, when I say, is within the network, single network. When we are connecting, what we use? We start with the LAN card or network interface card. So how many types of network interface cards are there? I assume that you are already aware of the topologies. So the selection of the network interface card depends on the topology which you are using. For example, if we are using star topology, that means we have to use 10 base T cards. If we are using bus topology, we have to use 10 base 2 cards. 10 base T cards are used for physical star and they provide speed of 10 Mbps and along with the twisted pair cables. So if you're using a 10 base 2 card, then you will be getting Ethernet standard along with the thin coaxial cables. Further, we have 10 base 5, which is thick coax cable with 10 Mbps, and 100 base TX, which is twisted pair high quality. Category 5 and above are recommended for this. And 100 base TX provides us the speed of 100 Mbps. Then we also have token ring cards, which are used in the token ring network topology. Earlier, we used to have token ring cards with maximum speed up to 4 Mbps, but nowadays we have up to 16 Mbps as well. Next, I'm showing you the examples of some 10 base 2 card, 10 base T card, so that it will be easier for you to identify when you go and buy the card in the market. For example, see, this is what defines, which makes it easy to distinguish for you whether it is 10 base T card or 10 base 2 card. See, this is 10 base 2 card. This is the BNC connector it has here, the arrow which indicates. These are the Ethernet cards. Ethernet cards have 10 base T cards which have RJ45 connector. RJ45, if you remember, we used to have analog phones. They used to have this kind of connectors. These are the RJ45 connectors. We also have, if you are having in case a hybrid topology, you are using both star as well as bus topology, then we can use the combo card which has RJ45 as well as BNC T connector. Let's move on further. These are simple connectors. Now you have bought a card, but you need a connector and the cables to complete the connection, complete the wires. So we have T connectors and the terminators. Terminators will ground the signal for us. Otherwise, data will move to and fro in the cable and it will keep bouncing back. So T connectors will be required along with the terminators at both the ends of the bus topology. See, this is how the actual connector looks like. This is the T connector and this is the terminator. Next we move on to the hubs. Hubs can be of two types, passive hub as well as active hub. What is the function of a passive hub? It is just providing the physical connection to the multiple devices in the network together. And in case of an active hub, it has built-in intelligence. It will be able to distinguish the network, break down the network into the one broadcast domain. And sometimes managers are manageable hubs as well. Hub management softwares make it easy for a user to check or troubleshoot in the network. They make it easy to manage the networks. Whenever a PC goes down in the network, lights turn amber in color, and if it's working properly, the lights will be turned green in color. So that is the reason that hubs are really very popular in the star topologies. It's very easy to troubleshoot. As soon as you see the light is turned amber in color, you can go and troubleshoot if it's a issue in a NIC card or a connector or a cable. It also supports SNMP protocol in the network. See, this image here shows a hub which is used in ring topology. You can see the ports and the lights which display the colors when a device is on. See, these are the lights. Here you can see these are the lights. And this is an example of a hub which is used in the star topology. Next, we move on to the repeater. Repeater is basically an amplifier. After, for example, if we are using 10 number of systems in the network, a signal tends to diminish or fade away. So the purpose of the repeater is to amplify the signals. In other words, we may say that we use repeaters to extend the physical span of a network. For example, if we are using 10 base 5 cable, the span is limited up to 500 meters. After 500 meters, we need to use a repeater. In this example, we show a repeater connection where node of PCs are connected to a repeater A and node of PCs are connected to a repeater B. This is another example of a repeater connection where the physical distance is extended using a repeater for an Ethernet cable to a thin net cable. Repeaters operate at the physical layer of OSI model, as you can see in this example. Some other devices which are also used for extending the span of a network are line drivers or short haul modems, but most popular ones are the repeaters. Next device which we are going to take in this study is a bridge. Bridges are used to connect two LANs operating under the same protocol. You must have heard of some protocols like TCP/IP, IPX, SPX. So we can understand from here that a bridge is used to connect a network which have the same protocol. So what is the purpose of a bridge? It facilitates the movement of data packet from one segment to another. It is not a very in-depth internet working device because it does not does any routing. It just provides two network segments, not multiple network segments together. So only two segments can be connected using a bridge. It operates at the data link layer of the OSI model. We can use two examples of a bridge here, local bridge and remote bridge. Local bridge is used to connect two different LANs located locally, and remote bridge is used to connect the LAN segments which are geographically apart. For example, if we use a dial-up access to connect a LAN via a bridge, that is an example of a remote bridge. Next device which we are going to undertake in this study is a switch. Switch is defined as a device that allows a LAN to be segmented on the basis of MAC or hardware addresses. But they use same protocol. So in other words, we can also say a switch breaks the network down into collision domains on the basis of their hardware addresses. A switch focuses on segmenting a LAN, whereas a bridge is concerned with linking two network segments. This is a major difference between a switch and a bridge. The purpose of a switch, it improves the network performance and reliability and allows better management of the network. The use of switches in internet working It allows to create multiple segments on the basis of MAC and hardware addresses. Switches are more common in use as compared to a bridge. See in this example, workstations are connected through a 100 Mbps switch. Switches also provide higher bandwidth. Next, we are going to discuss cut through and store forward technologies. What is the basic mode of operation of a switch? A switch operates using a receiver's address, sender's address, and then followed by the data. A data packet is analyzed, its receiver address is checked. If it is in the same segment, the packet is dropped. And if it is on a different segment, the packet is forwarded to a different segment. The two cutting switching technologies we are talking about is cut through and the store and forward. Cut through technology only reads the address part of the header and the packet is forwarded accordingly. Bad packets are not filtered in cut through technology. Whereas in store and forward technology, entire packet is processed and the bad packets are also filtered. See in this example here in this diagram, you can see the difference between cut through and switching technology. In case of cut through technology, receiver's address as it is received, the packet is forwarded further. They do not wait for the data. But in case of store and forward, whole of the header, sender's address, receiver's address plus data is stored and then it is moved further. Completely entirely goes into the store and forward and then it is forwarded further. Switching technology operates at the OSI layer and it uses MAC addresses, so it operates at the data link layer of the OSI model. And the sublayer of the data link is the MAC layer. Next, we move on to the routers. Routers connect LANs operating under different protocols. This is the most popular device being used in the industry. Basically, it is used to create subnets or network segments in the network. It is a true internetworking device. It establishes a logical path of communication between the sub-segments in the network. It allows to better manage the resources in the network and it can also be configured itself. See, this is an example of internet working with a router. Three different types of networks exist here. This is, let us say, one. This is the first network, this is the second, and this is the third. Different types of networks are connected using a router. They may have different types of protocols being used, but they can be connected via a router. This is an actual implementation of a network. You can see here the substations, the networks are connected. These are the substations you can see, or the nodes. These are connected using a hub which is connected to a switch and switch which is connected to a router. This is the practical diagrammatic implementation which you will often come across in the field of networking. What is the difference between routers, switches and hubs? Simply, hubs only provide the electrical connections. Switches, whereas they examine the packets on the basis of data destination address and move the packets further. And whereas routers, they examine and connect different segments together and move the packets according to the routing table information. They basically route the packets in the networks. So routers operate at the network layer of OSI model. You can see in this diagram also, it's at the network layer. So we can say layer 3 devices are routers, layer 2 devices are switches, layer 1 devices are repeaters. But we have one hybrid, that is layer 3 switches. These switches work both at the data link as well as the network layer, and they can perform MAC switching as well as IP routing. Why we use layer 3 switches? When we want a very faster router but also an expensive one. Traffic is longer local and speed of LAN is much faster. If we want to go into more deeper differences in between the layer 3 switches and the routers, we can use these two slides, otherwise you can skip these two slides. L3 switches do the switching by preserving the source, destination MAC, as well as the IP addresses, IP headers of the networks. Whereas in case of routers, they do normal routing lookup in case of the routers. But by introducing fast switching, packets are also now switched on to a router. Switches do not support quality of service features. Switches do not support the network address translation on the networks. The forwarding on the switches is based on the hardware based, which is on the chips which are being used, application specific integrated circuit chips. They are responsible for doing the forwarding on the switches. Forwarding on routers is rather software based, which is configured, which you can control using a routing table. And router also supports different WAN technologies, unlike switches. Last, we have gateways. Now, this is one device which yet I have to come across. I have never seen this device with my own eyes. I have seen routers, I have seen switches, I have seen hubs, I have seen the connectors, I have seen the repeaters, but not the gateways. So what is a gateway? Gateway is a device, comprehensive device, which is used to connect different types of networks together. These work on all layers of OSI model. They used to be really popular in the past, but not nowadays. In the present scenario, computers are now designed with due consideration to the network connections. And larger networks can be easily configured using routers, switches, and hubs. So in rare occasions, you may need to build a gateway. Gateway is basically any system which can be configured to act as a gateway. It will be a system. So in this example, when we will be using a gateway, that can be for connecting a legacy mainframe system to an Ethernet LAN. There may you require a device which will be configured as a gateway. So rule of thumb is basically gateways are used for interconnecting vastly different computing environments together, which we rarely come across. All of the devices nowadays support. For example, in this video, you can see this IBM SNA network is connected to the LAN Ethernet using a machine which acts as a gateway. And gateway operates across all layers of OSI model. I hope this was a clear explanation to the basic networking devices which we use in the networks. Stay tuned for more networking concept in-depth videos. Please subscribe and like my channel and comment if you like my video. Thanks for watching.